Hey guys, today we are going to move into chapter 6. So today we're going to focus on all polygons, and then that's 6.1, and then we'll move into strictly quadrilaterals. So we'll finish off the chapter with all types of quadrilaterals. But today we're going to focus on all types of polygons. So you first need to know what a polygon is. What does the word polygon mean? So poly actually means many, and gon means sides, so many sides. Um, Now, understand the actual definition says a plane figure that closes in a space using only line segments. So understand you have lines only, which means no curves. So you're not looking at stuff with curves. It needs to be line segments. Okay, oops, closes. No openings, closes. And then also make sure that you don't have any overlapping sides. So you don't want any, let's see, we'll do the bow tie. Here we go. So notice this kind of encloses two separate spaces. You want to enclose one space using only line segments. So basically look for no openings, no curves, and no lines crossing. No openings, no curves, no lines crossing. So let's classify. Um, some of these should look familiar to you. Some of these should look familiar to you. If it has 3 sides, you call it a triangle. 4 sides is a quadrilateral. Now, there's different types of quadrilaterals, but if you just have 4 sides, you just call it a quadrilateral. 5 sides is a pentagon. 6 is hex. And that's how I remember it. 6 is S-I-X. Hexagon is H-E-X. So they both have those X's. 7 is heptagon. A lot of people forget that one. 8 is octagon. 9 is nonagon. 10 is decagon. And then after that, they got a little lazy. So for like 15, you would call it a 15-gon. Or 20, you would call it a 20-gon. Now, 11, very rare that you're going to see 11. But 12, I will tell you they do have 12-sided figures do show up. They don't call them 12-gons. They call it a dodecagon. And that actually does show up quite a bit. But like I said, all the other stuff will be 11-gon, 13-gon, 14-gon, 15-gon. But 12, the dodecagon, does show up quite a bit. I can always get Ms. Blake, do I need to memorize these? You should definitely be familiar with these names because if a problem's talking about a nonagon and you have no idea what a nonagon is, now you can't do that problem just because you didn't know the vocab. So you definitely want to be familiar with all of the ones that are listed here. And you want to be able to know what that means, right? When I say heptagon, I need you to know that there's 7 sides. So first we're going to determine, is it a polygon? So here I see all straight lines, no curves, a closed space. So yes, that's a polygon. So we're going to name it. We're going to say 1, 2, 3, 4, 5, 6 sides. We're going to call this a hexagon. Might not be like normal hexagon, so it doesn't have to be regular. It just has to have 6 sides to be called a hexagon. Here I see a giant open space right here, so not a polygon. Has to be a closed figure. Again, this was kind of the example I gave you. We don't want any lines crossing because this is not one enclosed space. This is actually 2 like separate enclosed spaces. So again, not a polygon. Curves. No curves. A circle, and that's usually one a lot of people mess up on. A circle is not a polygon. Not a polygon. And then here, all enclosed space, all straight line sides. So yes, it's a polygon. We have 1, 2, 3, 4. 4 sides is a quadrilateral. Now, a lot of people mess up and they say, hey, this is a square. Do not assume it's a square. I promise later in the week we are going to get to squares. But you need some stuff marked to be able to tell me that's a square, right? A square has 4 congruent sides and 4 right angles. You need some stuff marked in here. If there's nothing marked and all you know is that there's 4 sides, then all you can name it is a quadrilateral. And like I said, after today, we're going to focus on all the different types of quadrilaterals, and you'll see what I'm talking about with markings. But today we're just identifying different types of polygons, all different types. So you can also classify polygons as regular or irregular. So regular are usually the shapes that you have in mind. Like when I say triangle, a lot of people will draw a regular, equilateral, equiangular triangle. But notice that the definition of regular is it has to be equilateral, so all the sides have to be equal. All the sides have to be equal. And equiangular, all the angles have to be equal. So that's an example of a regular triangle, equilateral, and an irregular triangle where the sides are not all equal and the angles are not all equal. Quadrilateral, again, if it's regular, all the sides are equal and all the angles are equal, and in this case they'd each be 90. So an example of a regular quadrilateral would be a square. A square is a regular quadrilateral. Again, over here, an example of an irregular, where the angles and the sides are not the same. Pentagon, 5 congruent sides, 5 congruent angles. And an irregular pentagon, where the sides are not the same, but there's still 1, 2, 3, 4, 5 sides. So it is still classified a pentagon, just regular versus irregular. 6 sides hexagon. Again, this is a regular hexagon, all sides equal, all angles equal, equilateral and equiangular. And an example of an irregular hexagon. And then same with octagon. I don't know if I can draw that tiny. We'll find out. All the sides are congruent and all the angles are congruent. All 8 of them. I missed that one. And a very, very irregular octagon over here. So just knowing the difference between irregular and regular polygons. We also have convex versus concave. So this is all based on diagonals. If you look at a convex shape, if you trace out this side, notice I never go inside my shape, right? If I trace out this side, never go inside. Trace out this one, never touch inside the shape. Never touch. Never touch. Unless, oops, unless I'm a bad drawer. But notice none of those go inside my shape. So none of those diagonals go inside my shape. However, if you look at concave, I'm going to change my color real quick. I lied. I'm going to keep it purple. Oops. Okay, that one never goes inside. That one never goes inside. So you're probably looking at it, you're like, what's the difference? That one never goes inside. Ms. Blake's crazy, right? And then you get to this one. Oops. Right? So I kind of call, in order for me to remember, I kind of call the inside the cave, right? If it goes inside concave, it's in the cave. And it also happens over here as well, right? When you trace out this side, oops. So that's the main difference. Look at those diagonals and see if it goes inside the cave or not. All right, so let's try some classifying. And I'm going to go back to my purple. So it says regular or irregular, and then convex or concave. concave, convex or concave. So right now I see two different angles. I also see a different side, so this is definitely irregular because all the sides are not the same length and all the angles are not the same measure. And then we want to know convex or concave. So see if we ever go inside the cave. Nope. 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 We never went inside the cave, so we're going to say convex. All right, here all the sides are equal, all the angles are equal, so we're definitely regular. And then see if you ever go inside the cave. Nope. 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 So we're going to call it convex. We never went inside the cave. Over here, now be careful because we see those equal angles and we want to say regular, but look at those side lengths. Definitely not regular. And you've got an angle here that's way bigger than all those other ones. So we've got irregular. Because those side lengths are definitely not the same, and all of our angles are not the same. And then convex or concave. Let's see if it ever goes inside that cave. Nope. Nope. Uh-oh. Right, we went in the cave. We're going to call this concave. All right, so that's regular versus irregular and concave versus convex. The next part is the polygon angle sum theorem. Basically says if you want to find out what the interior angles add up to, you've got a little formula here, and it says take the number of sides and subtract 2, multiply it by 180. Where did this formula come from? Well, it came from triangles. We know the angles of a triangle add up to 180, right? So if we look at a quadrilateral, if you start at a vertex and connect to the other vertex, you have 1, 2 triangles. So you would say 2 times 180. So we have 2 triangles. You would do 2, of those 180 degrees, and you would get 360 degrees. So a quadrilateral, the interior angles add up to 360. And you can keep going here. But the shortcut is this formula. So a quadrilateral has 4 sides, 4 minus 2, because we can make 2 triangles. And you say you have 2 of those triangles. So let's do pentagon real quick. So we're going to do the formula. So we're going to say 5 minus 2 times 180. So 3 times 180, and you get 540 degrees. So the interior angles of pentagon add up to 540. Octagon, 8 minus 2 times 180, so you have 6 times 180, and you get 1080. And then nonagon, 9 minus 2 times 180, so you got 7 times 180, and you get 1260. So using that angle sum for interior angles. Now the difference in these 2 directions, so notice these are both pentagons, but this says each interior, so they want 1. And they told you they're all regular, so they're all the same. So we know the interior add up to 540, and we're going to split it evenly between 5 sides. So 540 divided by 5, and we get that each angle is 108 degrees. Hept we didn't do, so that's 7. So we're going to do 7 minus 2 times 180. So 5 times 180 equals 900, and we're going to split it between the 7 sides. And we get each one is about 128 point, nearest tenth, so 0.6, because it was 5/7. So each angle of a heptagon. And a 15gon, so we're going to do it again. 15 minus 2 times 180. So 13 times 180 is 2,340. And we're going to split it between those 15 sides, 15 angles. and each one is going to get 156 degrees.